All right, math counts, here we go. We've got a statistics stretch today. So we're going to look at some basic statistics and what everything means for it. So let's start with average score. So average score is the mean. So what we have for an average score is the total of all the scores divided by the number of scores, and that's going to equal our average score. So let's say that we had 82 people taking a test, and their average score was 90. So X would be the total scores of the 82 people. Let's call them students. And let's say that their average score was 90 for all these students. Well, what would it take to change this score into a 92? So if I want to change their average by 2 points so that it goes up by 2, so their average is a 92, what would I have to do in order to get there? Well, if you look over here, what you would need to do, since there's 82 people taking the test, all 82 of those people would need to increase their score by 2 apiece. So in order to increase their average score, basically we would need to add 164 points in order to increase their average by 2. So this is a quick way for doing these types of problems. A lot of times they'll have problems, and you'll see when you do the stretch, where they've got an average and they want to know, well, how much will we need to, how much will certain people need to score in order to bring up that average? And it's just important to kind of think of it as how many total points do they need to bring this average up. So for instance here, we know that we want to bring the average up by 2. So that means the total points, since we're going to divide by the total people, the total points needs to be increased by 164 because 164 divided by 82 is 2 more points for the average. So sometimes looking at these problems backwards helps you to find out those types of questions. Let's look at stem and leaf. All right, stem and leaf is just a way to show a bunch of different numbers in a group of values. So what this represents is the stem is some kind of, it's either like the tens place or the hundreds place or something like that. So in this instance, what we're looking at is we're looking at 1, 2, 3, 4, 5, 6, 7 different numbers in our number set. And the stem and leaf is just saying, okay, this number is 0, 2, so 2. This number is 0, 5, so that's a 5. This number is 0, 6, so that's a 6. This number here would be 1, 3, so that's 13. This would be 1, 4, so that's 14. 2, 5, so that's 25. And then 2, 9, that'd be 29. So this stem and leaf is just saying, okay, we've got these 7 numbers. Now, stem and leaf is kind of nice sometimes when you are trying to find an average, because you can just add all your ones units over here, and then there are 2 of them in the 10 spots, so that's 20, and there's 2 of them in the 2 spots, so that's 40. So you could add all of these plus 60, and that's your total number, and then divide by a number like 7 terms over here. You can also find your median by using the stem and leaf plot, but stem and leaf is just another way to write down all of our number set. So this is just like a tens place or a hundreds place, I think, on your statistics stretch. So that's all it's saying is these are these points just written in a different way. Venn diagrams. It's never going to tell you to make a Venn diagram, but on certain problems, making a Venn diagram is probably the most useful thing that you can do. A lot of times these are when there's overlapping events happening at the same time. So for instance, I've made up a problem where we've got a whole bunch of people who are going out of town for work. And they can go out of town a lot of different methods. They can take a car, they can take a train, they can take an airplane, or they can do a combination of anything. So there's a lot of overlapping events in here. So I've got these three circles, and they all overlap in a certain way. So if I wanted to find out how many people took a car, car would represent everything in this circle. So it's not just 10, it's 10 plus 1 plus 3 plus 4. Those are all the people that would have taken a car. So that's a total of 18 people. If I wanted to find out how many people took a train, then I would use 2 plus 1 plus 3 plus 2. So there'd be a total of 8 people that took a train. So everything inside that circle. If I wanted to find out the people that just took an airplane, it'd be 6 plus 4 plus 3 plus 2. All those people took an airplane. So there'd be 15 of the people taking airplanes. Okay, so that's how to look at it in one way. You have to look at the terminology as well. So if I wanted people that only who take only a car, that would be these 10. These 10 people only took a car. Well, how many people took a car and a train? Well, we'd have to see where these two circles intersect. So over here is a car, over here is train. Where's the two intersections? Well, these people took a car and they took a train, and these people took a car and they took a train. So car and a train would be 1 plus 3, which is 4. All right, how many people did a car, a train, and an airplane? So car, train, and airplane . Can't spell today. Ooh, that's really bad spelling. I put an I in airplane. Okay, it's early in the morning, sorry. So there'd be 3 people who took a car and a train and an airplane. Now, a lot of these have to do with determining your ands and your union of where everything's happening at the same time. So they might say, you have to watch out for what they're saying. Car and train, remember, is 1 and 3, but only a car and a train would be 1. So these are the people that only took a car and a train at the same time. So setting up this Venn diagram really helps me solve these problems. Remember that anything in this circle represents people that took a car. This one is the people that only took a car. Whereas these two sets of people, this is they took a car and a train, and these are the people that took a car and they took an airplane. Whereas this one in the middle here, these are the people who took a car, a train, and an airplane all at the same time. So setting these problems up and reading them very closely is the trick. So you're going to want to write a Venn diagram when there's a lot of overlapping events that are happening at the same time, and you have to watch for the words only and. Remember, and is where they're intersecting. Only is where there's just a number sitting out there all by itself. So you're going to see one problems on your statistics stretch where you probably want to do a Venn diagram. A two-way table. Two-way table is when you're looking at two events that are intersecting. So here, our first event is we have males and females. We would call that an event. And then we would have bikes and no bikes. So that's the other event, is owning a bike and not owning a bike. So here we see that there's 40 kids surveyed. So I would say, okay, this is 40 over here. That's my grand total. Now I know that there's females over here. There are 10 plus 8 females. That's 18 females. Well, that tells me that there should be a total of 22 males, because the total males plus the total females should be the total kids surveyed. Then over here, I've got 13 plus 8, which would be like 21. So that's telling me that no bike is a total of 21 kids without a bike, which means that there must be 19 kids with a bike. And since there's 10 females with a bike, that means there's 9 males with a bike. And look when it's adding up this way, 9 plus 13 is 22. So these two-way tables, they should be able to add up with your totals of male and female over here, and then add up with your bike and no bike, and everything will add up to this 40 over here. So finding out maybe the percentage of males without a bike, there are 13 out of 40 students that are male without a bike. So we can find our percentages there. All right, last one is just looking at the algebraic mean, the median, and the range. So the algebraic mean, anytime they say that, is the average. So if I wanted to find my mean in this situation, I would just add up all these numbers and divide by the number of numbers. So 1, 2, 3, 4, 5, 6. There's 6 numbers, so I would divide by 6, 10, 30. So 10 and 20 makes 30, 40, 50, 64. So we'd add up our numbers and divide by 6, and that would be our algebraic mean. Our median is the number in the middle. Now, we set up here that there are 6 different numbers, so there's no actual number in the middle. So what we do in this situation is we find the 2 numbers in the middle. These are our 2 numbers in the middle here. And what we would do is we just take the average of the 2 numbers in the middle. So a plus 12 is 20. 20 divided by 2 is 10. So in this case, our median would be 10. That's the number in the middle. Now, if I had an odd number of values, so if 4 wasn't part of my value in my number set, I'd have 6, 8, 12, 14, 20. 12 would be my median because it's the number in the middle. But when you have an even set of data points, you take the 2 numbers in the middle and take their average. And finally, the range is the difference between the maximum and the minimum. So this would be max minus min. In this case, our maximum number is 20, and our minimum is 4. So our range would be 16. So that's just the difference between our highest number and our lowest number. All right, that's your statistics stretch. That's all you got. Enjoy. Math hard.